Hi friends, welcome to my YouTube channel where we are going to solve another question on the ladder and rotations. So based on this question, actually we need to understand what torques are. We are going to be using moments in other ways. You know, from grade 12 we learned about moment on how you find the moment if a certain row happens to be at the pivot, then you need to find the moment if you try to exert a force at a certain point. Now, based on these questions, they will also require you to have an understanding of moments. Basically, let me try to demonstrate something which is in grade 12. If your pivot is located somewhere there, you exert a force at this point. How do you find the moment? You say moment has to be the distance multiplied by the perpendicular force applied. So always moment, in other ways, we call it as torque, which is denoted by this symbol. It has to be equal to force multiplied by the perpendicular distance. Some applies even to this. If a force is not perpendicular to whichever distance, you need to make sure that it has been resolved, not until you come up with a component which is going to be perpendicular. By the way, you get back a bit to what is the relationship between friction and the normal force. What is the relationship between friction and the normal force? Friction force has to be equal to the coefficient of friction multiplied by the normal force. Same applies, and it has to be perpendicular. Normal force must always be perpendicular to the friction force. So since normal force is acting upward, if the object is on the horizontal floor, it has to be perpendicular to this the friction force that is applied. If you understand properly this question, you read it properly, they're telling us that we have two different surfaces. We have the horizontal surface and the vertical surface, which is the wall. Meaning that based on these same surfaces, we must also have something which is going to be a normal force. Remember, if this is to slide, meaning that it will be pointing in this direction, and yet its friction force has to be pointing in the opposite. I know that the ladder is going to be moving in this direction the moment it slide off the wall. It has to be pointing to the left hand side, and the so-called friction force will be pointing in this direction. So as the friction is trying to point in the opposite, the normal force must be perpendicular. It has to act at this point upward. I'm going to draw it somewhere there. It has to face perpendicular. I'll say normal 1, and this has to be my surface, whereby this one is oriented at 53 degrees. Okay, if you come on the wall, still more, the moment it starts sliding again here, there is no friction on this part, but you find that if we try to analyze properly, normal force must also be there. Why? Because this is something which is horizontal. And what direction will normal force act? Definitely, normal force is going to be pointing perpendicular to the wall again based on what you have. So normal force in this case is going to be pointing in this direction. I'll write it here. I'll say normal force has to point also in that direction from the wall, and this has to be my N2. If they're saying something is uniform, meaning that its whole weight or mass has to appear in its middle. So this row is having a force of, it is having a force of 400 newtons, meaning that that same 400 newtons must act in the halfway of this ladder, which is going to be in the middle. It has to point vertically downward. So even here, I'll write it somewhere there. I'll say my 400 newtons has to point in this direction. So if you check, that same 400 newtons is not even perpendicular nor parallel to whichever direction. So we can't find torques using that same thing. Why? Because the normal force, the weight force is not even parallel. What concept are we going to use at this point? We are going to use the concept of summation of forces in X and Y, as well as the torques. So a question might come, what are the two conditions that you are supposed to use for you to make sure that this body is in equilibrium? One, a body can be in equilibrium if the anticlockwise torques are equal to the clockwise torques. That has to be the first condition. The second condition is if all the external forces are balanced, meaning that the summation of upward forces must be equal to the forces in the downward forces. At the same time, the forces in x-axis must be balanced, meaning that that same thing is going to be at equilibrium. Two conditions. Summation of torques must be equal, and also external forces should be equal. Now, if you come to a simple understanding, what are we supposed to do for us to easily solve whatever you've been given at this point? What we are going to notice here, we are going to have friction. Why? Because the floor is rough. Then the wall is not even rough, but the normal force must be there. So what I'm going to do, I'll say the summation of anticlockwise torque must be equal to the summation of clockwise torque. That will be the first thing we are going to use. At the same time, what we are going to do, I'll say the summation of forces in X must be balanced. The summation of forces in Y must also be balanced. So you check what forces do you have in the X-axis and what forces do you have in the Y-axis. Remember, I'm saying if this is to move, it will move in this direction. Then the so-called friction force has to be pointing to the right-hand side. Why? Because it always opposes. Now, if you clearly understand what will be happening here, if you have a normal force pointing like this and yet there is friction, meaning that friction force here will be like this. Now, we are going to write our friction force as follows. I'll say friction force has to be equal to the coefficient of kinetic friction or static friction. In this case, has to be S, to show that we are dealing with static. Then you need to multiply by the normal force which is perpendicular to that same friction force at this point. We are trying to talk about N1. Okay, we are trying to talk about N1. Now, do you know that the summation of forces in Y, we only have two forces, the normal force which is going upward and the weight force, meaning that in this case, normal force which is N1 has to be equal to 400 newtons. You get, if you forget to solve this other thing, you can just equate N1 equal to 40. You get your answer from there. Now, what's the meaning of you having the summation of forces in the x-axis, which is going to be equal to 0? If you check, we are going to have a friction force pointing in this direction, which is this one. The moment this one slides to the right-hand side, why? Because the moment it slides like this, it will go to the right-hand side. Friction has to point in that direction. So since we have two forces in the x-axis, the friction and the one which is produced by the wall, it is also facing the x-axis. What we are going to do now is this. We are going to have a simple illustration by saying friction force here has to be equal to N2. Why? Because the same friction force is in line with that N2. And what is here? What is your friction force? Friction force is equal to 400 based on N1 multiplied by mu. So mu is unknown, and yet we have to find that same kind of thing. This will be my important formula that I'm going to use. How do you use torques? How do you use torques? To use torques, we are going to use a simple thing which is located somewhere there. And yet they're saying the ladder from here up somewhere there, it is having a length of 5 meters. But if you check the force which is located somewhere there, even these other forces, they're not even they're not even perpendicular. So we always take the forces on the floor, in short, this point as our pivot, meaning that we won't have torque at this point. Why? Because there is static friction, meaning that this kind of thing won't slide. Why? Because there is static friction. But we always assume to say it is going to slide for us to know the direction of tension, the direction of friction force, as well as what direction it will take the moment it is slide. So what we are going to do, since this force is not even perpendicular to the distance of the ladder from the pivot, what are we supposed to do? We are going to resolve now to make sure that its components are supposed to be perpendicular. If you come to this point, this force will also produce something which is going to be a torque. Now it is not perpendicular. What are we going to do? We are going to resolve it also. Remember, if you have 53 degrees somewhere there, even here you can have 53 degrees using alternating angles. Now, if you try to resolve it properly, you understand that if you have the angle somewhere there, And yet to resolve this one, we are going to have two components. One component is going to be perpendicular now to the distance of the ladder, which is going to have, if we have 53 here, even there, we are going to have 53. That's a fact. So if you resolve this one, the other component is going to point in this direction, but we're not interested in the component facing along the ladder. Why? Because it can't produce torques. Unless the one which is located somewhere there is the one which is going to produce torques. If you try to resolve this one, it will have two components. One component is going to face in this direction. Another component has to be perpendicular now to the ladder. It will be perpendicular to the ladder. How do you come up with the same components? So since we have an angle somewhere there, you are resolving this one, you must have something like this. As simple as that. Same applies to this part. The component which is going in this direction will have cosine. Now we're not even interested in this thing. Then the one which is moving in the opposite, this one is going to be n2 sine 53. As simple as that. Now we have the forces perpendicular now. This one is the one which is going to be used when it comes to calculating using torques. Same applies to that one. We are going to use the same kind of thing. If you keep on pulling using this force, you find that this ladder is going to take a clockwise direction. If you keep on pulling using this one, you find that it will take a clockwise direction, meaning that this torque this force will produce an clockwise torque, and then this one has to produce a clockwise torque. Why? Because these two forces now they are perpendicular. Let's try to solve this same question so that we understand what is happening. So remember I said we are going to be using the summation of anticlockwise torque has to be equal to the summation of clockwise torque. But in your mind, don't forget that we have something like this that we just got. I'll take this one to be my first equation. 400 mu equal to N2. Okay, now let's try to use a simple demonstration now. We said anticlockwise torques will be produced by this. So this force is located at the end of what? Of the ladder, meaning that we are going to do this. So since torques are supposed to be force, I'll say F1 multiplied by D1. I equate these two. How many forces do you have that are making a clockwise torque? We also have a single force. I'll say F2 D2. So remember, this force is located on the halfway of the ladder. Why? Because that's where the weight force is for the ladder. And the ladder is uniform, meaning that its weight has to appear in the middle. Okay, so what we are going to do now, anticlockwise torque in this case, our force is N2 sine 53 degrees. What distance do you have? We have 5. I'll say equate these two. Then the force, it has to be the component of the weight, 400 cos 53. The distance has to be half of 5, which is going to be like this. Okay, now I think at this point of time we'll be able to get what N2 is. Why? Because it's possible I can divide by 5 sine 53. Even here I'll do likewise, 5 sine 53, meaning that the second reaction force, which is N2, has to be equal to, if you punch this direct, remember this is just 1 and the same as 2.5, so I'll say 400 multiplied by 2.5 cos 53, divide this by 5 sine 53, you close, we are having 150, so we are having 150.711, I'll say newtons. By the way, if you get an answer which is going to be above 4, then try to get back a bit to your calculations. You are quite wrong. Okay, since N2 is equal to this, do you know that we have 400 mu equal to N2? we're interested in calculating for the coefficient of static friction now. Just equate. Take your answer there and you divide, you'll be able to find the coefficient of static friction. So 400 mu is equal to N2, meaning that we are going to have mu, which will be equal to 150.711. You divide this by 400. Then coefficient of static friction has to be equal to what? So let me try to divide the answer, dividing it. And yet your answer is 0.4. Wow, this is an amazing answer. That's how you solve these 2 mark questions. Know how to understand ladders, or rather torques, how to apply my torques. You need also to understand how to apply what we call the summation of forces in X. Try to subscribe to the channel, like, and share for more videos. Thank you for watching.